Hello everyone, I welcome you all to the next part of Euclid's geometry, and I hope that all the axioms, postulate and the theorem 5.1 which we have proved using the same is clear to you. Today we will see the equivalent version of the Euclid's postulate. So let us start with the topic today. Okay. What is Euclid's fifth postulate? I have already told you it is very significant in the history of mathematics. Okay. We have learned the postulate was if two lines have a line intersecting at P and Q, so the side which have sum of angle less than or equal to 180 degree, that side if both the lines were extended, they will intersect. So see how its equivalent version states and what does it signifies more. We see that by implication, no intersection of line will take place when the sum of measure of the interior angle on the same side of the falling line is exactly 180 degree. So we have proved that less than 180 degree it would be intersecting. So let us see if they are 180 degree, what would happen. Greater than they won't intersect, all we know. But if they are exact 180 degree, they will be parallel. Okay, so this is what you have learned in other formulas that the sum of angle is 180 degree. So here comes the Euclid's postulate. There are several equivalent versions of this postulate. One is the Playfair's axiom, given by Scottish mathematician John Playfair. Okay, as stated below, for every line L for every point P not lying on L, there exists a unique line M passing through P and parallel to L. Okay, so he stated this postulate. Playfair's axioms can also be stated in the following form. Two distinct intersecting lines cannot be parallel to the same line. Okay, so if they are intersecting, they cannot be parallel to the same line. Consider the following statement. There exists a pair of straight lines that are everywhere equidistant from one another. Is that statement a correct consequence of Euclid's fifth postulate? Explain. So, in order to solve this question, just come with me. Okay, just listen to me very carefully. I'll be taking a line. Okay, suppose this is A. Okay, and I'm taking a point B. Okay, by the Euclid's fifth postulate equivalent, that is Playfair's axiom, we have already learned before, there will be a line which will be passing through point P and at the same point parallel to L. So there can be any line. Okay, so this is the line suppose, and this is N. Okay, now we'll draw the perpendicular distance from P to L. Maybe the distance would be D. Now we know that for a fact that any point from M to L perpendicular would be same as this length D, and every point from L to M perpendicular would also be same to D. So this state that this equidistance from one another and there exists a pair of straight line and this equidistance would be same for ever. So hence this statement is a direct consequence of Euclid's fifth postulate. Yes. And we have explained it using Playfair axiom. Okay, I hope this question is clear to you. This was a bit tricky question, but the explanation is very easy. Okay, now we will quickly revise all the concepts we have learned so far in Euclid's geometry. First concept. Though Euclid defined a point, a line and a plane, the definitions are not accepted by mathematicians. Therefore, these terms are now taken as undefined. Axioms and postulate are the assumptions that were obviously universal truth. They were not proved. Theorems are statements which are proved using the previous axioms or postulates or the other theorems being proved. Okay, some of the Euclid axioms were things which are equal to the same thing are equal to one another. If equals are added to equal, the wholes are equal. If equals are subtracted from equal, the remainders are equal. If the things coincide with one another, they are equal to one another. The whole is greater than a part. Things which are double of the same thing are equal to one another. Things which are half of the same thing are equal to one another. Now, what were the postulates? First was a straight line may be drawn from any point to the any other point. A terminated line can be produced indefinitely. A circle can be drawn with any center and any radius. All right angles are equal to one another because they will coincide obviously. Fifth postulate, which was a bit tricky, if a straight line falling through two straight lines makes the interior angle on the same side taken it to be less than 2 right angle or 180 degree, then the two straight lines produced indefinitely would intersect at a point to the side. Okay, so this was fifth postulate. Two equivalent version of fifth postulate: for every line L and for every point M not lying on L, there exists a unique line M passing through P and parallel to. So we have used this postulate in the last question. Two distinct intersecting lines cannot be parallel to the same. All the attempt to prove Euclid's fifth postulate using the first four postulates were failed, but they lead to the discovery of several other geometries called non-Euclidean geometries. Okay, so this was all for the lecture. I hope the Euclid's geometry chapter is clear to you and you will be able to solve any question given to you. Thank you so much for listening to me. Thank you.